Hello my dear students, today we are going to solve a very important definite integration problem step by step with the full conceptual clarity, and the question is find the area under the curve fx is equal to x to the power 5 into e to the power x square between x is equal to 1 and x is equal to 2. So mathematically we need to evaluate I is equal to integration of 1 to 2 x to the power 5 e to the power x square dx. Okay, and the four options are given. Option number A is the 5 by 3 e to the power 8. Option number 2 is 4 by 3 e to the power 8. Option number 3 is 7 by 3 e to the power 8, and option number 4 is 1 by 3 e to the power 8. Now let us solve this carefully and intelligently. Okay, now look at the integrand x to the power 5 e to the power x square. Whenever you see the polynomial into exponential and inside the exponential you see, your brain should immediately think the substitution method, because derivatives of x square is 2x and we already have the powers of x outside. So substitution is clearly the correct approach. Now rewrite x to the power 5 is equal to x to the power 4 into x, right? Why? Because we want 1x dx pair of the substitution. So the integral becomes I is equal to integration 1 to 2 x to the power 4 into x into e to the power x square dx. Right? Now we proceed with the substitution. Now let t is equal to x square. Then dt is what? 2x dx, right? So x dx is half dt. Then convert remaining term. So x to the power 4 is x square whole square, that is t square. Now substitute everything. So we get I is equal to integration of t square into t to the power t into dt by 2. Okay, so we get I is equal to half of integration t square e to the power t dt. Okay, now since it is a definite integral, we must change the limits. When x is equal to 1, t is equal to what? 1 square, that is 1. When x is equal to 2, t is what? 2 square, that is 4. So the new integral becomes I is equal to half of integration 1 to 4 t square e to the power t dt. Okay, now solve this integration. Now this requires integration by parts, right? So we use the standard formula, integration t square e to the power t dt is equal to e to the power t into t square minus 2t plus 2. This is the standard repeated integration by the parts result. So I is equal to half into e to the power t into t square minus 2t plus 2. This will be 1 to 4. Okay. Now apply the upper and the lower limits. So first substitute t is equal to 4. So this becomes e to the power 4 into 16 minus 8 plus 2, that is e to the power 4 into 10. Now substitute t is equal to 1. T is equal to 1. So we get e to the power 1 into 1 minus 2 plus 2, that is e into 1. Okay, now subtract. So we get I is equal to 1 by 2 into 10 into e to the power 4 minus e. So the final answer for this question will be I is equal to half into 10 e to the power 4 minus e. This is the correct evaluated value of the integral. Now look at the given options very carefully. Okay. All option contains e to the power 8. But our final answer contains e to the power 4 and e. This clearly tells us either the function was misprinted or the exponent in the question was actually different, because with e to the power x square, maximum exponent at upper limit becomes e to the power 4, not e to the power 8. So if exponent was x to the power 4, then at x is equal to 2, 2 to the power 4 will be 16. If exponent was 2x squared, then 2 into 4 is equal to 8. That could produce e to the power 8. So based on the given function, x to the power 5, e to the power x square, none of the given options are correct. Okay. So whenever solving the definite integrals with the substitution, always change the limits. Always check the exponent behavior and match the final answer structure with the options. Now in the competitive examination, if options are in the terms of e to the power 8 and your calculation gives e to the power 4, immediately recheck the exponent inside the exponential. That saves 2 to 3 minutes in the examination. Okay. So the correct evaluated integral is half into e to the 10 e to the power 4 minus e, and none of the listed options match this result. Okay. So this was the whole solution for this question. I hope this is clear to you. See you in the next video with a new question. Till then, bye bye and take care.